Tellor Oracle. Tell us about Tellor.
Yes. So there's another service that you can. So here's the thing. So to be a validator takes 32 million PLS, which could be somewhere 3,000, 4,000, 5,000, depends on the price of PLS, right? One day it's gonna be tens of thousands of dollars to be a validator. You know what I mean? I'm hoping.
Wow.
Right. I would like for that to happen.
So.
We'll see. Speculating on price there a little bit. So there's another service that's forking Tellor oracles on Ethereum. It's not called Tellor. The Liquid Loans team is forking Tellor technology, say like the technology that's powering a couple different EVM networks on Ethereum called Tellor. It's similar to Chainlink, but it's different. It's not the same. So they're forking that technology, creating a new service with a new native token. And the way that service works is so there's a product called Fiat. It'll just launch on Ethereum. It'll be on PulseChain. Liquid Loans, Power City, their liquidity fork. Like really the liquidity forks are the ones I'll talk about. They require a price oracle to tie the ratios between two things to a US dollar price. So if the PulseX exchange, right, the DEX, PulseX DEX has ratios, those are prices between different assets, derived a USD price because say Pulse is tied to Ethereum on Ethereum, and then now Pulse has a price, and then that comes back over to Pulse Chain. Everything on Pulse X is tied to Pulse basically. So then now everything that's on Pulse X has a price ipso facto because you have to derive a price because everything else in the chain has a price.
Right.
So you can derive a US dollar price for everything. Now you can aggregate those prices. You could call directly PulseX to get it, which is kind of the default because it's the native DEX for a Pulse chain. But you should probably get your data from other places. So like say Pulse and Hex and all these other assets that are on Pulse chain, not Ethereum, but on Pulse chain, they're going to be on centralized exchanges. The price feeds are going to be aggregated through, say, CoinMarketCap, even though on that one, CoinGecko, a little bit like that too. But these websites exist and they have prices and they aggregate exchanges. So the prices the assets that are on Pulse Chain are going to be traded on centralized exchanges. They're going to be traded on other DEXs, not just PulseX, right? Other DEXs are going to exist on Pulse Chain. So there's a service called Tellor oracles that will take all those different data points, do like a time-weighted average price, and then there's a central party, an oracle service that can like aggregate that price, and then now your app is getting the price aggregated across all these different applications and these different services for your application to do, whatever it is that it does, right? It's an oracle. What I like about it is the fact that if you want to be a Tellor reporter, then the price point is much, much lower than say being a validator. Even though if you can be a validator, please be a validator. You know what I mean? But if you can't be a validator and you only have a tenth, if you only have like 3 million PLS, then hold that PLS. Awesome. Good job. But if you really want to run a service on Pulse Chain, then maybe you want to run an Oracle service. You can run a server. It's like a lightweight web server, 8 gigs of RAM, VPS.
Could you have it on your own validator server? You run both at the same one?
I mean, I wouldn't run it. Like most things, I'm gonna say, like if you're running a validator, you shouldn't do anything else with that computer. And if you're running a validator, you should run it in your house and be as decentralized as possible. Now, this Tellor reporter, you're not running that from your house. The latency wouldn't be that great. And the way this service works is you have a application, Liquid Loans, right? Because they're forking it, right? So Liquid Loans, they want the price of PLS, the US dollar price. So what they do is they call the Tellor service, whatever it's called, and the first Tellor reporter that can get that price from all these different sources and then give it back to them gets the fee. And then all the Tellor reporters are in the cloud Hopefully they have very little latency. So you're going to be you want to be in a data center that has really great internet, that's low latency. It's like, like a web server, right? If you want to have a really nice website, then when somebody goes to your website, they can't wait a minute to return the website, right? You want it to be fast enough in the milliseconds that it's basically instantaneous for them. The same thing for Tellor services, right? So you run it in a data center. It could be in Europe, Asia, the US. I mean, basically wherever you think your customers, the people who are going to need the prices are, then you can try and put them as close as possible. Or different data centers some are better with latency and some are not. Like if you have it's pretty basic stuff, but so if your customers, the 90% of your customers in the US, and then you're not going to put your servers all only in like Beijing. Well, not Beijing, but like Singapore and like India. Like DigitalOcean has a data center in like India. Like the latency is going to be in the hundreds because it's like all your customers are in the US and then your servers in India. Right. It's like on the other side of the globe. So you probably want to like put that in the US. There's like
we have the technology, we have the technology to communicate across the globe. They have pipes underground.
Yeah. Well, latency is the amount of time it takes, right? A call to be received and then response. Yeah. So, you can, although it does technically work, maybe you want to put your server, your telereporter in an area where most of your customers are. That would probably be in the US, maybe in Europe, wherever. So you can figure that out. It's totally up to whoever wants to run that, but it's a decentralized service that's going to be all over the world. And then you're effectively competing with the other telereporters to be the first one to give an accurate data point. And then if you give an inaccurate data point, then the other telereporters on the network can say, hey, I challenged that. And then there's a whole process on how to challenge that. And if you were actually, in fact, right, then you get the fee or part of that fee as opposed to them. And, there's an arbitration, like an automated arbitration process where you're challenging these data points. So what you need to do is basically run the configuration for these is already done for you. You basically just load in the pairs of, you could run multiple, say like USD PLS, USD Hex, USD PulseX. You can run all those in the same server, but then you're going to be staking this token like multiple times. And then you're going to be providing a feed that is like for multiple assets. And another thing about it is you stake multiple times. So how you can run a validator, and you can run 100 validators on the same computer. We can do the same thing with a telereporter. You can run multiple assets, but then, so if you stake one time, say like 10 of these tokens, and you stake only one time, that means you can provide a price feed, like a request only once every 12 hours. But then if you do 12 times, that'd be like 120 tokens. Then you could provide a price every hour. And then you could, obviously, the more times that you stake in increments of 10, then the more often you can provide a price feed, which means that you're going to be able to, when there's a call, to provide the price, get that fee, and then you'd be more likely to, receive the fees, right? As opposed to like everybody else. So, it's kind of like mining, but it's not really, you're not really mining with a SHA-256. You're just available. And if you have really good latency, then you can see the call first, call out to the places that you are getting the feed from, package the feed, and then give it back to the end user. And then hopefully you're the first one, and then you get the feed. And that's only possible if you staked and you have the ability, like you've staked enough times, or you're open to providing the price in the first place.
It sounds like you're publishing.
You're publishing a price on demand. And so if you stake enough times and you're available to publish the price, then when someone needs the price, then you can just publish it, and then you can get that fee. Is basically how it works. I published cool. In the chat, I put a link about it. Let me see if I can do it again here. Yeah, here. So I did a 30-minute overview about it. I'm providing education on obviously validating, which is the thing that we talked about. Like I talk about that all day. But then I'm also providing education on how to be a Tellor reporter. When it is live on PulseChain V4, I'll do a tutorial on it. I'll run my own on testnet. And then there'll also be a thing where I can walk people through how to do it, which, although it's really, really simple, it's a Python program. You install it. Just like being a validator, right? You have to install some clients, get it configured in the right way. And with being a validator, you have to deposit a certain amount of tokens. With as a Tellor reporter, you load it with an address, right? With a private key that signs the transactions, similar to being a validator, because the validator key is a private key, and that's how you can sign transactions so you can publish blocks. Very similar for Tellor reporting, or really any kind of like validator, like a bridge validator or a Tellor reporter or a blockchain validator. They use private keys to sign transactions to prove that they have the ability to sign. And then obviously there's the if they do a bad job, there's slashing for validating, slashing for being a Tellor reporter, and like that. So yeah, so you have to set up in a certain way. Security is a problem, right? You have to worry about security, so you need to make sure that you set it up with SSH keys, set it up with the right firewalls. The service that you go through, obviously your user, the website that you go through, which a lot of people don't think about, is, do you have 2FA? Right? Are you using a strong password? Maybe you use an email that you don't use for anything else, so that somebody can't just break in through the dashboard and then take over your server and then do, I don't know, bad things. I mean, whatever they can do with a validator. Which would be, if you're running a validator in the cloud, those would be the same concerns, right? Firewalls, access to the actual server, access to the dashboard to create the server, because obviously there's built-in mechanisms to regain like access to servers through the dashboard, like DigitalOcean, right? You can reset the password to get access, because sometimes, well, it's kind of a common thing. I've done it myself, where you start the firewall, but you forget to allow 22.
Yeah.
And then you lock yourself out of the server, and you're like, oh crap. And then you go through their dashboard, the DigitalOcean dashboard, and then there's a process where they have to confirm that you are in fact you. They send you back a link to your email. And then what they do is they manually reset your server to allow you to be able to get into it,